All right, so we'll go ahead and dive in. So today we're going to explore what's new in SolidThinking Inspire 2018. And just by way of, the agenda today, we're going to, do a quick introduction to who we are, Boundary Systems, and also a quick introduction to Inspire as well. And then we'll talk about some of the new features that are in Inspire. I guess at least the two main ones in Inspire Structure. And which is basically consists of the overhang geometry support for additive manufacturing, and also the support now for lattice structure generation in the structural concept shape. After that, we'll do a live demonstration where we'll show you some examples where we're using Inspire, and then we'll get into some Q&A, and you guys can get to ask as many questions as you want. All right, so let's just go straight in. So who are we? So we are Boundary Systems. So we are a product development consulting company based out of Cleveland, Ohio. But really we have an international reach, and we love to help customers, in anything from, product development to simulation to, CAD design and consulting, to also, product lifecycle management. Really, we like to say, anything where you're trying to design a product, be it from concept to, it being fully, produced, we can help in any step of that design cycle. And one of the tools that we use to, to do that is Inspire. Now, this entire presentation technically isn't intended to be, a full soup to nuts, detailed overview of what SolidThinking Inspire is. We've done many other webinars on that, and so if you're completely new to Inspire, I'll talk a little bit about an introduction to it from here, but you may want to go watch our other videos to, to get more context. So what is SolidThinking Inspire? So Inspire is a concept design platform that allows, design engineers to really, to create structurally efficient concepts very quickly and easily, right? So you understand, how a product is supposed to be loaded, and you can very quickly, have Inspire come out with the best shape to structurally load that particular object. So that way you're designing your products much faster, right? Because Inspire comes up with these concepts in 15 minutes or less, right? So you're not having to spend hours waiting on a concept generation to complete. And because you're designing your products with the best starting point in mind, your designs are then much smarter, and I guess you'd say you have more quality in them, right? Because you're less likely to fail, due to structural effects. And then finally, you're also then designing them such that they're going to be lighter as well, because you're not putting in any extraneous material where you don't need it, right? All right, and part of the reason why Inspire, is unique in the product development cycle, and the reason why it's so incredible to use is that the typical design process you have, in this case you'll have what's it called, you'll develop a concept, right, over on the far left over there, and then from there you go ahead and create some detailed design, right, which then goes into either some form of computer validation, either through hand calcs or FEA, and then also some prototyping as well if you have the ability to do that. And usually then that prototyping and detailed design phase becomes iterative, right? Because you test something in a simulation and you realize that, oh, the stresses are too high, or it's not going to meet up to whatever structural design criteria we have, or oh, we want a max deflection of 2 millimeters in this location, but it's deflecting by 5 millimeters, right? So again, that's out of our product definition specifications, and so that validation and detailed design section just becomes iterative, and you could loop in there 4, 5, 6, 7 times just trying to narrow down to a good design. um, before then, heading to production. Now, that's where Inspire comes in. So the goal is with Inspire at the start of your design process, right? Inspire can take into account the structure, the way your model is going to be loaded structurally, and then give you the optimal shape to design for that. And so then your detailed design is then based upon an Inspire concept, which then means that for validation and prototyping, usually you'll see very little iteration, maybe one or two iterations, right? Not or even none at all, because you're starting with structurally the most efficient concept shape. And so, when it comes to strength or stiffness or rigidity or flexibility or things like that, Inspire will be able to design your model to meet that target from the beginning or from the get-go, right? Which then means you spend less time in that detailed design validation loop where you're just iterating back and forth. And then that also means that in Inspire as well, one of the things you can also do is you can also specify some production intelligence into it as well. So for example, if you know that you're going to design something either as a casting or as a machining or something, you can have Inspire take that into account when it's generating the concept shape, right? So that way it gets you more, for example, more casting friendly geometry. So when you go to production, you're not having to spend a whole lot of time fixing poor geometry errors that make the casting not easy to produce, right? And so again, that also helps to shrink that production side of things as well. And with the goal then being, you shorten your time to market with Inspire at the start of your design process. Right. All right. So diving into some of the things that are new in Inspire 2018 that they've added recently. So Inspire. So this, I guess, overhang geometry support is one of the main things they've added, and this is really meant to, to target the additive manufacturing side of things. So for any people that are using Inspire in an additive manufacturing context, this is where it's going to help a lot. Now, just to step away from Inspire for a second, with additive manufacturing in general, you typically always want to have, supports. Whenever you're building something that, or any geometry that overhangs, above a certain angle without any structural material underneath it, right? So, for example, in the screenshot that's on the slide there, um, the image on the right is essentially a 3D print of the letter T, right? T for Tom. And you'll notice, underneath the side arms of the T, that there's some, vertically, that there's some structures that are protruding downward, right? So those are essentially the support structures that are holding that side arm of the T up, right? During the build or during the print. But then the problem with that is once you're done printing that, the build quality right where the support meets the main structure because it's not as great as if it was just the full T without any supports. So you're degrading build quality in that location, right? You also have cases where the surface finish, right, would also be affected because once you're done with this, you'd also then have to remove the supports, right, and then that would affect the surface finish in that location. Not only that, but you're also then what's it called? Intentionally increasing your production time because for every ounce of support that's added in order to build the model, that's additional work after the print is done to where you're going to have to remove those supports, right, in post-processing. And so adding supports just means you're intentionally increasing the amount of post-processing time that you're going to eventually have to end up doing at the end. And so ideally, if you can 3D print something without any supports, usually that's the most ideal, right? Usually if the structure itself is self-supporting, that's usually very ideal. Now on the left, you have the opposite side of things where, there's no supports at all, and then, the print just goes, completely haywire, right? Which you definitely don't want to have, because this looks almost nothing like the letter T, right? And so you definitely don't want what's on the left, and, what's on the right is a necessary evil that, if you have a choice, if you have a choice, you want to avoid, right? And so that's where, Inspire then comes in. Because Inspire is generating, concept shapes, you can then, with Inspire 2018, what they've added is the ability for Inspire to generate a shape that meets an overhang angle up to a certain criteria, right? So say, for example, now the overhang angle depends on, it's usually, a lot of times material specific and printer specific, right? And so usually that's going to vary depending on, what printer you have. But say, for example, we're investigating different overhang angles, right? Now this is just a simple screenshot, but this essentially here shows, for a certain object, for that overhanging surface that's at a 45-degree angle, that's how it's going to look like compared to if we say, hey, let the overhang be a max of 65 degrees, right? Then this is going to protrude outward even more, right? To allow that 65 degrees, right? Now this is more of a cantilever, right? And so, but again, you can see how the structure changes from, between different overhang angles, right? What they've added in Inspire is the ability for you to specify what this angle should be, right? And Inspire knows as it's generating the concept shape, as it's creating something that's structurally efficient for you to build, it's not going to create anything that violates this overhang angle, right? And so that way, whenever you're done, whenever Inspire is done, generating the concept, you have a confidence that whatever you see on the screen, you can put in the printer in that particular build configuration, and it will print upwards, without needing any supports, right? Which then again will dramatically save you material, and also save you a lot of time post-processing, and also then potentially not minimize the build quality, because you're not then having to have any surface roughness, or I guess surface finish issues wherever support material meets the parent material. And so that's the biggest. That's one of the big highlights. And then the second major highlight is with Lattice Structures, right? And with Creo, sorry, with Inspire, we'll just pause a quick second here. I think my PowerPoint just died on me here, so let's try this again. Okay. Yep, sorry about that. That's what happens when computers decide to do their own thing. Okay, so with Lattice Structures, a lot of times you'll see, different, objects in engineering like this. So for example, in this case, the Eiffel Tower, right? And one of the reasons why the Eiffel Tower is so popular when it comes to additive manufacturing is that the entire structure is self-supporting, right? It's hollow, right? You don't have any like solid, flat walls or anything like that in there. It's just made out of a repeating set of lattice, cells that makes it very light, at least comparable to if it was made entirely out of concrete or something. Makes it very light, but yet also incredibly strong to where it can support its own weight, and also support, for example, side wind loads and things very easily. And so the ability to create something like that, inside of a product or a structure, inside of a product, becomes very, very daunting, because, I mean, you could just think of, for example, using your CAD program, Creo, for example, to build each and every one of those tiny beams, inside of the Eiffel Tower. That would take a while. And then also placing them and sizing them correctly to where that they're within a critical load path, and they are going to bear the load, and they're not going to be overly stressed, right? And so what Inspire has added is the ability to have the software automatically generate a lattice structure within a specific space to fill that space with a lattice structure, right? And so in this case, Inspire is automatically, figuring out the length of the lattice, cell to use, the size of the lattice, to use as well. And it's sizing all of those based on the stresses that it's seeing in that particular location, right? So it's not just a blind fill where you just say, hey, take this random shape, fill it with lattice entities, and I hope to God that that my stresses aren't too high. No, Inspire is checking against your stresses, and it's sizing those lattice members appropriately. And then the other thing that then makes Inspire Lattice really cool is that you're then able to take those and export it as an STL, and go straight to a 3D printer. And again, with the freedom of additive manufacturing, you can start to 3D print your lattice structures, and now you have incredibly light objects where you have, for example, 90% material removed, but you're still within your structural limits for what you want, for the load that you want to bear. And again, this is just another example of, I guess in this case, sort of a honeycomb lattice structure that's used on a building. I believe this building is in Belgium. But one of the other things that I'll mention about Inspire Lattice before I continue is that and not only does it, size the lattice cell appropriately, but Inspire is the only software of its kind currently in the industry that will also give you a mix of lattice and solids as well, right? So if you have a case where you're trying to, so for example, if you have a case where you should not have a lattice in a particular location, maybe because it's experiencing a lot of stress, and ideally it'll be better to have solids in that location. Inspire will tell you that. Inspire will tell you, hey, if you lattice this area out, you're shooting yourself in the foot because you're significantly weakening the structure. So it's better to have solids in this section and then everywhere else have lattice, right? And there's no other software in the industry that does that. So Inspire is incredibly smart in how it generates the lattice, a concept where it's not just blindly filling everything with lattice and hoping for the best, right? All right, so at this point I'll pause here and we'll switch to a live demonstration of the software. All right, so in this example here, what we have is just an airplane bearing bracket. I got this this geometry and the loading conditions off of a GrabCAD challenge. I believe this was a challenge that was done by, I want to say it was Alcoa or GE, one of the two. I want to say it was Alcoa. They sponsored a challenge with GrabCAD where they had this airplane bracket, and they gave you the loading conditions, and you had to design, and this is going to be additively manufactured, and you had to design the structure as light as possible to go from start to finish essentially. And this purple block is the design envelope. So whatever you build must not be outside the bounds of this purple block. So it can be smaller but not bigger than this purple block, right? And so if you start to take a look at it here, you'll notice how it's symmetric in this case. And if I sort of tilt to the top over here, you'll notice there's some like bolt fastener locations in the middle where this object can be bolted down, right? And then the forces are all applied over here. So one to the horizontal, to the bottom, and then at an angle. And all those forces are applied at different load cases, right? So it doesn't see all three at once. It could see either one of those three in different configurations. And Inspire can solve for multiple load cases together and give you the structure that supports all of them, right? Inspire can also solve for things like, pressure loads, right? Torque loads, displacement constraints if you don't want a particular area of the model to deflect more than a certain amount. You can also have what's it called, gravity loads in the model as well. In this case, all we had were just force loads, so we just had that. We just have that in there. And whenever we're taking a look at some of the results here, we'll switch to those so that way we can see the. Actually, we'll do this. So I'll start off here with this guy. Okay. And so yeah, so in this case, this is sort of the initial Inspire run with, I don't believe there were any shape controls in this case. So this is just a free run. Inspire can do whatever it wants, and you'll sort of notice how the software starts to so again, from where the load is applied, right, it starts to hollow out the material and shows you only where you need that material, right? So it says, hey, this inner radius here, that's critical. You need all that material, but this outer radius here, you don't need that much. You can start to shave off some material there, right? And then also, whenever we look into here as well, you'll notice it's building sort of an I-beam-like structure, right, where you have, sort of this, flange in the middle, right? That's going to be bearing a lot of that weight and then making it as stiff as possible, right? And again, because a lot of it can be organic whenever it's designing, it'll start to look somewhat, odd where, I don't know, for example, if I tilt into it right here, you start to have these random, nooks and pockets in here as well, and these random truss structures. But again, overall, you get an idea of what the software is trying to do, what it's trying to build, right? Now, one of the things that we also know, for example, in this case, is that when we 3D print this, it's going to 3D print, on a certain printer. And say, for example, in this case, we know what our printer is, and we know that the printer likes an overhang angle of, for example, 60 degrees, right? And so in this case, within Inspire, we can specify that using this overhang angle shape control, right? And whenever you have that, you basically pick the face where, I guess you pick the bottom of your print direction, right? So the direction from which you're going to be printing. So if I'm going to be printing it from the left, for example, I can go ahead and just pick that face, right? Or from the bottom, I can left click and pick that face, or from the top, I can just left click and pick that face, right? If you also want to, change, the orientation of it, say for example, you want to print this at an angle, you can also start to move that as well and say, okay, let's say, we're going to print this object, when it's at an angle like this, for example. You can start to move that print direction plane, right? So it's very flexible in how you can specify, what print direction you want to use. But once you're done specifying that, you also then give it an angle, right? So what the maximum angle that you want it to print from and not go beyond, right? In this case, we specified 60 degrees, right? And once you specify that, it's done, and then you can start. You can then have Inspire run and generate some new geometry for you. So in this case, we already have that result. So we'll flip to it here. All right, and let's see. I believe it's okay. Yeah, it's this one right here. Yeah. And so now you'll notice some of those additional, truss structures that were over here on the side. Inspire has gotten rid of those now because it says, hey, those guys violate the 60-degree criteria that you gave me, so I'm going to get rid of those guys, and I'm going to add more support material in the middle here, right? Also, so for example, these surfaces, right, these areas right here, all of these support that 60-degree overhang angle, right? Likewise, these surfaces right here as well, and definitely this over here, right? And so now I do have the confidence that if I take this, straight to a 3D printer, it's going to print, and I'm not going to have any overhang angle issues, right? And so that's one of the key things about Inspire is, for example, even if you look at right here, so you'll notice initially in the original shape that I had, this is almost looks like a perfect I-beam, right? So there's a very small radius right here. Inspire's just saying, hey, this is going to be a flat plate at the top and just a big web in the middle, right? But in the case where I tell it, hey, I want a 60-degree overhang, now it knows, okay, I can't have such a drastic change in angle because that's almost going to be a 90-degree angle. And so then Inspire fills it in with a whole bunch of material like that, right? So now you'll see it's not just going from horizontal flat to vertical flat. Now it has some sort of a huge fillet in the middle there, right? And so again, it's taken all of that into consideration, making sure that you can take this concept shape, right? Either create an STL from here and immediately send it to your 3D printer, or you can take it to your CAD program, whatever CAD program you have, and start to detail out your geometry based on this shape. And then you can 3D print that. And if I'm printing this on a printer that supports a 60-degree overhang angle, I will not need any supports for this entire geometry, right? And so that's the beauty of Inspire, being used in this particular example here. And again, the whole goal of that is you're saving time, right? Because you don't have to have it print out the supports. That's saving you some build time, and also that's dramatically cutting down on your post-processing time because you're not spending time removing supports that are already going to be in the model, right? All right, so next question, next highlight or next feature to show here is going to be the lattice feature. So we'll switch to a different model, not a different model, a similar model for that one, but we made a couple changes. So in this case, let's see here. So this is essentially the same model. The only difference was, taking the inspiration from the original baseline model that we had. You noticed that the Inspire was basically moving you towards sort of an I-beam sort of shape, right, where you had just a flat web in the middle that was bearing a lot of the load, right? And so we decided, okay, well, let's try that. So let's we took this back to our CAD program, created that middle profile, right, of that I-beam, right, and then brought it back in here. And we isolated that as its own design space because one of the things we realized from within Inspire is that not all of that I-beam is bearing a lot of stress, right? We were able to run a very quick FEA analysis in Inspire, right? And it said, okay, yes, this is structurally stiff, but this wedge here, is not bearing too much stress. You could still lightweight this a little bit more. So then we brought it back into Inspire and said, okay, let's see how we can do that using a lattice, optimization. And in this case, for the lattice, Inspire has the ability to do that now, where you can specify that you want it to create a lattice structure, right, inside of the object. And here, what you'll do is you'll give Inspire some a range to work within. So, for example, you'll give it a target length of each lattice beam, and then you'll also give it a range, so the min and max diameter. So, what it can't be less than or greater than min or max diameter for each beam. And again, this is something here that's unique to Inspire, right? The ability to tell it to fill the structure with, 100% lattice, so that way everything is a full lattice, or some combination of solids and lattice. So 80% lattice and the rest 20% solids, right? And so that then means that you can start to see areas where it may not be wise to fill with. It may not be wise to fill with lattice because a solid may be better in that position depending on what stress that object is seeing in that location. Yeah, and then you just go ahead and let it run, and Inspire will generate those concept shapes. And so now if I go ahead and and show a couple of examples here. So in this example here, what we have is, so let's see. Yeah, so what we have is, a lot of these, and I'll zoom into them so that way you can see them. A lot of these lattice beams, adequately sized appropriately, right? And now, all that remains is, you can just go ahead and take this and straight to 3D print, right? And you'll notice the other thing about this is, we'll give it a second here while it's thinking. And okay, yeah. And so what I just did over here is I just selected the what's it called, the smooth option, smooth lattice, and you'll notice from the prior screen, Inspire then created a lot of like smooth fillets right around each intersection point where the lattice meets, where all the lattice members meet each other. But now you'll notice what we have here is essentially geometry where it's entirely latticed and hollowed out, almost like the Eiffel Tower, right? It's structurally efficient in supporting each other very well, right? Yes, we know that these areas of the lattice structure are are experiencing higher stress than, for example, these other areas right here. But in general, everything is supporting each perfectly well, right? Now, this is something we can go ahead and take to a 3D printer and start to 3D print, right? Now, to the point of varying the density of the lattice members, or I guess varying the thicknesses. So we can switch over here to lattice diameter, for example, and we can start to show. So as I scrub through this, let's see here. Okay, yeah. So in this particular example here, Inspire didn't use any variable density. Yeah, actually it did. So you'll notice right over in this corner, as I start to vary the slider of that lattice diameter result window, you'll notice how some of these elements start to appear and disappear, right? So that's saying, hey, some of these lattice members here that are currently disappearing are less than this particular value, right? And the ones that are still visible are greater than that, right? So in this case, in those specific corners, Inspire is varying the size of the lattice members, and it's not just something where you blindly put in a value and you hope for the best when it comes to the stresses. All of this is intelligently considering what the stresses in the model are. Likewise, in this other example here, what we did is essentially a very similar run. The only difference is we told Inspire to also run this where it's generating 90% lattice instead of a full lattice structure in the entire shape. And now you'll begin to see areas where Inspire says, hey, if you gave me only 2 pounds of mass and you told me to stick it somewhere, I would put it right here, right? So now this is something where in a design review, we can start to compare and say, hey, do we want to entirely lattice out this entire shape and look at the stresses on that? Or do we think it's better to, keep solids only within this region, right? And then everything else we can hollow out, right? We're still going to be incredibly light, right? But again, we're not going to be sacrificing, strength, at least when it comes to these areas of the model right here, right? And so that's the beauty of using Inspire, where you can start to generate these different lattice structure concept shapes and start to then see how that what's it called, makes your model structurally lighter and yet without compromising structural integrity. So for example, both of these lattice concept shapes I'm showing you here, whenever you take a look at the the mass of the model compared to the original baseline. These lattice shapes are within what's it called? For this particular design space here, that was the lattice a lattice entity. Those lattice shapes are within what's it called? I would say about anywhere from 60 to 75% lighter than just the original, than just the original purple block that was there, right? So again, you're saving, 70 or something percent material without compromising strength. And that's what they've added in the newest version of SolidThinking Inspire 2018. Sweet. Okay, so that covers it for what I was going to show here with some of the things that are new. I'll switch back over to our PowerPoint and we'll wrap up. So again, just to sort of to recap this, why does it matter? Well, these matter because now you can again in keeping with designing your products much faster, right? So without having to what's it called? Yeah, so without having to iteratively decide, oh well, where do we want to put supports and how many supports do we want to have, and again then having to post process those supports, or even figuring out how to create the lattice structure and just going off of blind faith. Inspire can generate that much faster and much smarter. And you can then start to lightweight your products incredibly using the power of lattice, and then going straight to an additive manufacturing solution, like in this case a 3D printer. And so as a result, you're able to get your products to market faster, and then yeah, and that's it. So at this point, we'll switch over to some Q&A. If you have any questions, again, you can type them in the questions panel of the GoToWebinar control panel, and we'll take a look at those and see what questions we have here. All right. So so the first question is, what export formats does Inspire offer? In terms of, and I assume that's speaking about taking the concept shapes, from Inspire back into whatever program you want to use it in. So when it comes to the structural concepts that are non-lattice based, those can be exported in any geometry format. So you can export those as steps, as edges, parasolids, any neutral CAD format that that you can use to export a solid, you can use for those. And so usually what I do with those is I either use the polyNURBS functionality in Inspire to detail out the full CAD model, or I export that as a parasolid, bring that into, in my case, Creo parametric, and I essentially then have the Inspire model, in my Creo part, sort of as a reference or as a trace. And so that way, while I'm creating my extrudes and my revolves and things, I'm not just randomly picking dimensions. I'm starting with essentially the best solution in mind as I'm sketching inside of Creo. And then when it comes to the lattice structure that we saw at the end over there, that lattice shape can be immediately exported as an STL, which you can then take to a 3D printer and print right away. Cool. Other questions? Cool. It doesn't look like we have any other questions here. Or actually, yeah, one just popped up. Do you have any influence on the cell shape that Inspire uses for the lattice structure. And if I'm understanding that question, I believe that's speaking to, I think it typically with latticing, there's sometimes when, you can specify different cell shapes or sizes, either if it's a square shape or if it's like a hex shaped lattice, or if it's, or even the screenshot I showed, during the PowerPoint where it was a building with a honeycomb lattice structure. And so I believe that question is asking, do you have any influence on the shape of the cell that Inspire is using when it lattices out the entire model? The answer for that is no. That's not one of the variables to influence. Really, in this case, all you influence is the length of each lattice member, and also the size of the lattice member, and you do that by the min and max diameters. And Inspire then has the ability to choose, what diameter it wants to use for what member, depending on how much stress that particular member is seeing in that orientation. Okay, so another question here is, does SolidThinking offer parametric surface modeling tools to help create these organic shapes? So for that would be a no. SolidThinking directly, they offer not parametric surface modeling. It'd be more subdivisional surface modeling, almost similar to pushing and pulling a piece of Play-Doh. And it's in Inspire, it's called polyNURBS modeling. And so yeah, they do offer polyNURBS modeling to create these organic shapes into essentially CAD models. And you can and you can use that within Inspire to generate those shapes from the organic concept shapes. But when it comes to parametric strictly, there's nothing that SolidThinking offers. Usually you would flip that back to an existing CAD platform that you would have. In my case here, if I want to create something from an Inspire concept that's parametrically driven, I bring it back into Creo Parametric, which is what we use. Yeah. So hope that answers your question. Cool. So it looks like that's all the questions we have. Once again, thank you so much for joining us in this week's edition of Boundaries Webinar Wednesdays. If you have any other questions or comments, or you need to reach out to us, our information is on the screen. If you need if you have any things about technicalities of how Inspire works, you can email me or give me a call. Or if you need anything regarding sales, what's the dollar cost of Inspire or things like that, that would be a Steve Seymour question, and his information is on the screen as well. Once again, thank you so much for tuning into this edition of Boundaries Webinar Wednesdays. Hope this was very helpful for you, and we will see you on a future edition of Boundaries Webinar Wednesdays. Thank you. Bye.